last year, 2022, there was a heist, a case involving a Linux implant, and we researched it. It was involved with a more or less $30 million US heist. So that was quite interesting, and we decided to investigate more Linux threats, what is happening in the wild. So we're looking forward to show you a summary of those threats, and more importantly, like how can we have visibility on those, like what are the detections that we can make on those. So that's the goal for the presentation. My name is Pedro Drimel. I'm a researcher at BlackBerry. The first time I flew in the US was in 2009 for a SANS conference. I took the intrusion detection training, for lots of TCP dump and all that. So it's quite nice, like 13 years after being at SANS event again as a speaker. So thank you so much for that. I'll pass over to my friend Jose Luis.
Okay, thank you so much, Pedro. My name is Jose Luis Sanchez, also known as Joselillo, coming from the south of Spain. As Pedro said before, we are going to talk about Linux threats, what we were researching during 2022. So starting with the presentation, we have this agenda for today. First, we are going to talk about a small introduction about some concepts that we think that are necessary for understand all the presentation. After that, we have the Linux in the wild threats, where Pedro is going to talk about some families that we were tracking last year. Following that point, we have the similarities and detection, some processes that we did in order to get some correlations and say similarities during the different infection of the Linux threats. And finally, we have the conclusion and different outcomes that we have generated also for the audience. So the first slide, the introduction is, let's say that first of all, we want to talk about these two concepts because during the entire presentation, we are going to mention probably many times the concept of GTFO bins, which is let's say a list of binaries, sometimes pre-installed in the operating system, sometimes are not pre-installed, but are widely used by threat actors and also by IT admin, for example, or IT security analysts that are used for, let's say, or try to avoid some detection in the operating system. It's the same concept that probably all of us know, which is the other one, LOLBAS. It's the same concept, quite similar, but in this case for Windows, where we have libraries, binaries, and scripts that are also used by many threat actors during the operations. Both concepts are going to be used during the presentation. So first of all, common behavior, let's say, this is not always the same, but the key points from this slide is that I want to show you, let's say, that in the Windows campaigns where when you are reading some report from some vendor, there are, let's say, many different states during the infection. So if we go to the specific detail of all the steps made by the threat actors, we are seeing several payloads like downloaders. We are seeing Trojans. We are seeing the final payloads, the final family that the threat actors are trying to deploy. Also, if we go to the specific detail of each step made by the threat actor, we are going to see many LOLBAs used, which is quite interesting because sometimes we are not, let's say, having focus in detect some of those LOLBAs. We are just setting ILCs related to some specific family used in Windows. So another key point on this slide is that sometimes, not always, but there are some CVE exploitation during the entire intrusion in this kind of operation. It's just a common, let's say, behavior that we are seeing, obviously, in all the reports made by the different vendors. And in Linux, we have something quite similar at the end, multiple states. They are, let's say, deploying downloaders, deploying Trojans, and finally getting some, let's say, the end, some ransomware, encrypting all the data in the operating system. But it's quite similar because they are also using GTFO bins. We are going to talk about some of them during this presentation. And the difference here is also that the initial vector is not let's say, an email, because as you know, probably Linux is not the best option or the best in the organization to have as an endpoint for the end user, are more like related to Linux servers. So the initial backdoors usually is maybe a CV exploitation, maybe a lateral movement from another previous infected machine, or some cases also we are seeing some valid credentials from the dark web used to log into the this kind of servers. So same here, if we go to the detail, we are going to see some GTFO beans used during the infection. Finally, some of the LOLBAs and GTFO beans that we have serving are these. Obviously, we are missing some, like PowerShell is also one of the most used LOLBAs in Windows operation. Just an example here, some of the most used that we are serving tracking Linux threats during the last year. Symbiote, for example, is quite similar in terms of behavior as we have in Linux. Let's say wget or curl, we can download file using those binaries. So it's just an example, and some of the two different lists that we have created. So now, Pedro, please talk us about the Linux thread that we were tracking.
Thank you. So those are the families that we have listed. I'm not going to go through all of them, only some of them, but this list is just to can you guys hear me now?
Yeah.
Okay, good. So I'm going to go through some of them, but the research itself and the data that the rules and all that we're going to provide at the end that are going to be in our GitHub page involves all of them. So first, talking about Symbiote, it is basically a backdoor keylogger. We published research last year with Intezer, and the interesting part is the exfiltration capability it has, and it has also a very stealthy user-land rootkit. So if you list directories, you won't see it. If you check process, you won't see it. If you check the network traffic locally, you won't see it as well. Maybe, in my opinion, at least the most interesting part is, so basically it hooks libc and libcap, but it even removed the stat. So if you're locally, doing your CP dump, and it filters out the domains, the IPs and ports that it doesn't want to show up. And it also removed that from the stats. So like you see exactly the number of packs you're seeing on the screen. I like that one. And it used DNS for communication. So of course, we've seen many other threads using DNS, but for Linux, this was quite interesting to see. And they also use public key and private key schema as well to check if the command received from the command and control is really provided by the attacker itself. So that was quite unique. And the usage of DNS cat for exfiltration. So if you're monitoring a network, you see some unusual DNS traffic for Linux blocks, make sure to check it out. And why is that relevant? Like, all right, just piece of code running Linux on Linux system. There was actually 4 victims confirmed. They were in Brazil, and one of them is related to a fraud in more or less $30 million. So that's quite relevant. It maybe kind of helps a little bit when we as a community kind of think, oh, why do the Latin America threat actors, these two are in fraud and not all in ransomware? Maybe some of them might still have some success. So of course, the Symbiote was not the only tool used. Linux was not the only system attack, but it was a relevant part on this attack. Basically, uses of valid credentials. It's coming as maybe a normal thing right now, and it was a very old local privilege escalation. As we're going to see later as well, and others, basically for Linux threads to be successful, you do need, or it's also required to use some type of local privilege escalation exploits. And it was the code was compiled locally, which so you can just wget and then compile locally. You're not going to see that on a Windows environment where a threat actor will like fire up your Visual Studio and compile the code locally. But that was the case. The tool itself, it's not clear if it's like a local threat actor. It doesn't seem so. So that was quite interesting. But the attacker with the domains they use, it kind of we believe it was a local threat actor. Moving on Orbit, another this was published by Integer, and it's basically it has the rootkit stealthy capabilities for the same as Symbiote, or very similar at least. So here, like we can see the directory is listening, but I can easily see my the strong password from my friend Jose here. But it also has an interesting aspect of using dropper and payload that was not very common from the Linux side. And you can even install it and execute it on a shared memory, so it's non-persistent on the system at all. Or you can choose a directory you want to install it on a given directory. And another interesting aspect of Orbit is that it tries to patch the system loader binary. So whenever a new process spawns in the system, it will execute Orbit. So that's a way to avoid. So for example, if the admin finds, oh, that it's patching the LDSO preload, it also tries to use this second technique. And it also relies on Python, which is one of the GTO beans that we've seen for escalation, basically. So they create a user, fixed user ID on the system, and once that user logs in, it will execute bash through Python. Lockbit, of course, we should. There's always some ransomware involved, and it targets VMware ESXi. We've seen Lockbit 2, Lockbit 3 as well. It's common to say, yeah, it's targeting Linux, but in a sense, most of these big ransomware players we've seen, they are targeting primarily ESXi. It doesn't mean that if you have a Linux environment or which in your data you shouldn't care, but if it's ESXi, you should care much more about that. And why is it relevant? So this we could not confirm in terms of the sample itself if they really fixed this, but there was a bug bounty of $50K for someone who found a bug in the encryption algorithm for their Linux encryptor. So if they're willing to pay that amount of money, means they are really serious about that, which is seeing criminals paying bug bounty is a bit scary, but yeah. Also, some generic Trojan downloaders. There are many of them. This one is so using lots of GTFO beans. So they use like curl to download something. We've seen lots of XM rigs and generic coin miners as well. So just download something, execute it. There's nothing fancy, but it does a job. We've seen, for example, exploiting the Confluence remote exploit from last year as well, and just using coin miners. I believe on the Windows side, if there's like a remote exploit, they won't just install coin miners, but on the Linux front, they do that a lot. This is a fully featured ransomware, also using just GTFO beans. So the usage of OpenSSL basically to encrypt the whole directory. This is just an example, and again using wget a lot. This is an interesting sample, which is basically a fake Zoom installer. We thought would be nice to share this because it's really well written. So it pretends to be installing a Zoom binary, while under the hood it tries to exploit the Pi vulnerability. And it uses the code that is available on the public exploit. So even the user it creates with the same password, so it's not a modified exploit. And then again, more GTFO beans. So like it tries to execute reverse shell using bash pretty much, and exfiltrate the data using curl. So getting all the files from the home directory and sending to the remote IP. And here's the using echo to create a file. And of course, here's the connection getting timeout. But if it was the reverse shell was running, that would be executed. So these are the summaries for those threads. I'm passing over to Jose now.
Okay, so we have seen some insights related to some of the threads that we were tracking last year. And something that we did in that case was multiple different processes. For example, this one was in order to get some, let's say, detections in the operating system after execute some of the Linux threads that we were seeing with Pedro before. So Cybercriminals is an open source project that you can download from GitHub. Is used to get detection related to Sigma rules. You can execute, for example, any malware in your system. After that, execute Cybercriminals, and let's see if you have any public Sigma rule in the official repository, detecting some specific behavior used by that specific piece of malware that you have executed. So in this case, you can see the red box. Several detections were found during the execution of the detection installer. And we have also created 3 different Sigma rules that we are sharing in a public GitHub. At the end of the presentation, we are going to show you some others Sigma rules that we have created for some of the threats that we were researching, because the behaviors that we are detecting in those specific Sigma rules that we have created are generic behaviors, are not related to some specific piece of malware. So it is quite interesting to get in your infrastructure. Another thing that we usually do, and for this specific research made by all the different threats that we were tracking, was create, let's say, attack flows in order to get all the understanding, all the knowledge about how it works when it is executed. Why is this useful for us? It's useful because we can see all the different ETF being executed and also the different steps made by the threat actors. But I am not going to comment everything from this slide. Just I will comment briefly that you can see in the screen different colors. The meaning of the colors are the severity of the Sigma rule that are triggering some specific behavior in the system. So, for example, if we go to the red color, the red box is related to a process create event, which means that has a Sigma rule with high severity detecting that specific behavior. And the cool thing here is that if you click on the specific box, you are going to be related to the Sigma rule in order to get it easy and simple. So as you can now, probably after the summit, you are going to get the presentation and you can click and get those different behaviors that we are triggering during the execution. Okay, so finally, the section related to simulators and detections is more, let's say, similar to the flow that we saw before. But first of all, we have created also a tree map with all the techniques used by these threat Linux that we were researching. Something cool. We have done the same with all the rest of the families that Pedro was talking before. For time, obviously, we can't comment every tree map with every family, but in the end of the presentation, you have all the slides and all the tree maps generated for the Linux threads. And another cool thing that we did, similar to this one, to the tree map, is create navigator layers of MITRE ATT&CK with all the TTPs by every thread that we were researching in this presentation. So you have exactly the same information, but in a JSON format, just to use it and for your own purposes and see if you want to, let's say, start your strategy in Linux environments. Okay, so quite related to the MITRE tree map that we saw in the last slide, we have also generated this matrix, which has the, let's say, the different technique used across the different families that we were tracking. So it can help you also to get your strategy in Linux environments and focus or start doing this in 2 different ways. The first one is threat-centric, and the second one is technique-centric. If you want to do it in a threat-centric format, probably you want to focus on those threat families that are using most techniques during the entire campaigns that we were researching last year. On the other hand, if you want to focus your strategy in the technique-centric, probably you want to focus on those that are with a value of 7 or 6, because that means that that technique specifically was used 7 or 6 times during the different infections. So it's another cool thing that you can use in order to, let's say, prioritize your security efforts in your organization. Similar to the flow chart that we saw before related with the entire intrusion with the different steps made by the threat actors, we have also done something called activity threats, which is a concept of the Dion Model for intrusion analysis paper. And the goal of this activity threat is, let's say, split all the different steps by the threat actors in different, let's say buckets. The buckets are the different kill chain phases. So we have done this with all the families that we were tracking last year. In this case, you can see, for example, the DT5 intrusion, which was split in different kill chain phases. So with that, what we are going to try to achieve is, let's say, get patterns in some specific phases of the kill chain, helping us to, in the future, who knows, get some attribution based on patterns or behaviors, similar behaviors, shared by some threat actors in different intrusion. For example, in the table of the right, you can see the different events with a specific action made by the threat actor. And number 5 is just an installation of that service in the system, as you can see. But we made the same with all the entire Linux threads, but not only focusing on the malware execution for itself, focusing on the entire intrusion. The malware was just a piece of a step made by the threat actor, but they were also using other pieces of malware during the infection. So as I said before, what we are trying to do here is get the data into buckets in order to focus on some specific kill chain phase and get the information that the threat actor were doing in that specific phase. And also this can help us to clustering and attributing in the future in our CTI processes. And with the same information of the threat activity, with the outcome of that threat activity, we have created also a Dion model, high Dion model, with the patterns that we have observed in all the intrusion during the 2022 Linux threats that we were researching Pedro and myself. So this is also, let's say, a good approach to start focusing or to start doing some strategy in your organization related to Linux threat, because here we have some of the patterns that we were observing during the last year and can be useful in order to prioritize those security efforts in your organization. So you have there all the capabilities that we have observed during the last year, also the infrastructure, the infrastructure or the different steps made in that specific part of the Dion model. Yeah, I think that will be nice, no, to start doing some stuff related to Linux threats. So Pedro, please.
Wrapping up here, some conclusions and just few recommendations. Of course, we could have way more, but I believe, previous escalations from all the attacks you've seen is always needed. There were at least 16 local previous escalations from last year, so that comes down to first recommendation, system patch, nothing novelty here, but and we've seen, like I mentioned, some remote exploitation not necessarily leads to advanced attacks, like coin miner being installed on system. On Linux, we've seen also lots of open source usage, like Tiny Shell, very old piece of code, Charles Wright as well. Even Symbiote downloaded like from using the source code. So they do not really care about protecting it. Of course, if we compare with the Linux world or with the Windows world, there were lots of leaks on the cybercrime scene from early 2012, 13 until 2015. So for example, Carbear or Zeus leak, but those were all leaks, right? Here they're just giving out source code to someone else. That was quite a difference that we found, and it has lots of simple stuff like those XMRig and other coin miners, but it can turns into advanced backdoors, as we've seen with Symbiote and Orbit as well. And just using like OpenSSL and a few other tools, GTFO beans can turn into a full feature ransomware. And for recommendations, like I mentioned, system patch being one interesting one. On the network side, do not underestimate and Linux traffic, as we've seen, so like DNS traffic coming from them. And yeah, sweet bits is still relevant. Most of the attacks we've seen, they still use, sweet bits for escalation. So that's something to check in the system, of course.
Okay, and finally, as I said before, we have generated different outcomes based on this presentation. So you have in our public GitHub 5 Sigma rules that we have created covering behavior from different families that we were tracking. And also you have the attack navigator layers for those threat families that you are seeing there. So hope it will help you to start doing stuff in Linux. And I think that's all from our side. So thank you so much for your time. And there you have our social media.